One of the most dangerous delusions about behavior-driven development is the idea that BDD scenarios are requirements and they can just be delegated to somebody to write and pass on to other people. This is misleading and dangerous. In this video, I want to dig deeper into the origin of this whole idea and help you get the most out of the process of specification by example. In the late 80s, Gerald Weinberg and Donald Gauss wrote a book called Exploring Requirements, where they suggested that one of the best ways of checking if the requirements for a bit of software are any good is to write what they called black box tests against them. They argued that the requirements can get very complex, so they become difficult to reason about. Requirements also need to be relatively abstract because they are determining the scope of work on a larger level, and as such, they're not that easy to argue about. Yet, to make sure that we're building the right thing, we absolutely need to be able to reason and argue about the requirements in detail. Tests, on the other hand, according to Weinberg and Gauss, usually end up being very detailed and concrete, making it easy to reason and argue about them. And in the book, they explore this connection between requirements and tests, suggesting that we might be able to reason about requirements by reasoning about test cases. For example, a while ago, I worked with a digital platform where people purchased credits for downloads and then downloaded digital resources built to those credits. One of the key requirements was to allow downloads only if users had enough credits in their account. Everybody seemed to understand that well, it was easy, it was simple, until a tester came up with an interesting edge case. What if the user had $9.99 in the account, but the thing they were trying to download costs $10. We had a bunch of people in the room when discussing this, including one of the key business stakeholders, the sales director. Almost everybody looked at a test case and said, well, it's obvious. We should reject the download. You have $9.99 in your account. The thing you're trying to download costs $10. The sales director was confused with this, and he said that it's clearly a case when the download should go through. We asked him to explain why, and he said that it's in the spec. And we said, well, where is it in the spec? And he pointed at the word enough. And he said, people should download if there is enough money. Look, $9.99 for something that costs $10. Clearly, there's enough money. And we quickly understood that what he meant with enough was not the same as what the developers thought was enough. He then had to explain things like funnel drop-offs, card purchase completion rates, and how on a large number of transactions, it's clearly better for the company to allow small discrepancies where we reduce the cost per transaction and the profit per transaction a bit, but we increase the overall number of transactions, making the whole thing more profitable. This was quite a complex domain rule with limits that existed only in that person's head until we pulled them out and defined them. And these were the real requirements. I'm paraphrasing now, but the key thing I took away from the Exploring Requirements book is that it's difficult for people in general to explain what they want, but it's very easy for them to complain. A stakeholder might not be able to clearly explain what a nice-looking app means, but they can tell you that something's ugly when they see it. The sales director in this case could not define upfront what enough meant, but he knew that he did not like the $9.99 option as it was presented. With a few other examples like $9.98, $9.50, $9.70, we figured it out together very quickly. In order to complain, people need something concrete to complain about. And the first time that people usually get something concrete to complain about is when they start interacting with implemented software. That's why iterative delivery works so well. We put stuff in front of users quickly, we get feedback and adjust. But implementing software is a very expensive way to learn. One of the key arguments in the Exploring Requirements book is that we can get almost the same effect by writing black box tests, and that we can write black box tests much faster than writing software. So from that perspective, the tests are there because they're concrete enough for people to complain about. Effectively, if the tests are not easy to agree on, then the conclusion is that the requirements are not well defined. Good requirements lead to test cases that people can agree about. Unclear or overly complex tests are a signal that the requirements are not that good. That, in essence, is the key idea behind behavior-driven development and specification by example. People tend to understand given when then scenarios as requirements, and then the stakeholders are supposed to write them and give them to developers to make things more concrete. No, they are not requirements. They are examples that are concrete enough so we can quickly try having a fight about them. The way I practice spec by example is to get those examples out as a very quick way to surface disagreements and wrong assumptions. We can use acceptance tests written with examples to quickly discover areas where people do not have shared understanding about, so that somebody, some domain expert, a business stakeholder, somebody who's going to do research, can clarify those things and provide the knowledge and the expectations. Those are the actual requirements. What's particularly important about using examples for those kinds of discussions is that the happy day scenarios, generally provided by business users when developers insist that customers write BDDs, are probably not that useful. Everybody will agree on them. Going back to what Weinberg and Gauss wrote about, the tricky examples are the ones that people will complain about. We want the boundaries, the edge cases, the areas where people might end up disagreeing, and curiously, examples of edge cases, boundaries, and weird behaviors are exactly what makes good test cases.
We're extremely fortunate to be sponsored by Equal Experts, Transfic, and Octopus Deploy. Octopus makes it easy to deliver software to Kubernetes, multi-cloud, on-premises infrastructure, and anywhere else. They automate the release, deployment, and operations of your software and AI workloads with a tool that can handle continuous delivery at scale. All these companies, though, offer products and services that are extremely well aligned with the topics and philosophy that we discuss on the channel every week. So if you're looking for excellence in continuous delivery and software engineering in general, do click on the links in the description below and check them out.
To make things more practical, there are two good techniques that you can use to get this kind of value from your BDD scenarios and tests. They are the use algorithm and feedback exercises. The use algorithm is a great way to come up quickly with difficult boundaries and edge cases. I came up with it while working as a consultant with lots of different companies to help them facilitate discussions around examples faster. Use is an acronym for usual, structure, edge cases. One easy way to discover difficult edge cases is to figure out the right domain structure for an aspect of functionality we're trying to describe. Does it have strings? If yes, then try an empty string, a string with just spaces, a string with very long data, a string with special characters, a string with umlauts, a string with tabs. Does it have dates? Try the start of the month, the end of the year, leap hour day, 24 hours, 00, 23, 59, 59, 59. Does it have multiple elements of the same type? Try the same value, try very different values, try the values close together, try them far apart. Those kind of heuristics are very easy to come by online and in testing books. Some will apply to your situation, some will not, but generally you can use these heuristics to very, very quickly tease out useful examples of edge cases to discuss. However, to get to a structure, we need a few simple, usual examples that are not that complicated, and then look for patterns in them. So a quick way to get to the E, the edge cases, is through the S, the structure, and the U, usual examples, in reverse order. So that's exactly how we got to the 99910 scenario. We started with a statement that people should be allowed to download the resource if they have enough credits. The two usual scenarios for that would be that a purchase is allowed, obviously, and another one where the purchase is not allowed. So we try to define some obvious examples, the usual examples. And if somebody had $10 in the account and the resource cost $5, well, obviously allow the download. If they have $5 in the account and the resource costs 10, well, obviously don't allow it. This is a usual example. Now, with these usual examples, they are the step one in the process. Unfortunately, with most BDD scenarios I've seen with clients working with them, they tend to kind of stop at the usual examples and hand them over, especially if they were written by a business stakeholder. They're not good boundaries. They're not things that people will be able to complain about. Usual examples are step one of the algorithm, not the end of the discussion. Don't stop at them. And instead, look at the structure, look at the edge cases, and start discussing them. In this case, the structure, we started looking at this, and there's an account balance, there's the resource that people wanted to access and the cost of that resource, and there was the decision, should they be allowed to download it or not. We wrote out these three things in a table so we could clearly see them. That's step two. And then step three is to look at the structure and start applying testing heuristics to that to get to the edge case. We had numbers, so large numbers, small numbers. We had two numbers, well, numbers close together, numbers far apart. And this is how we got to the 9, 19, and 10 scenario. It came out as a result of playing around with these testing heuristics very, very quickly. It took just a couple of minutes. And it was concrete enough so that a stakeholder can complain about it. We got useful feedback much, much, much faster than going and implementing the software. The other important technique for this is called the feedback exercise from the book Sources of Power by Gary Klein. The book talks about improving decision-making in situations where people have different and limited levels of domain knowledge, and they need to make important decisions under a lot of time pressure. So there's not enough time to analyze everything in detail, which is kind of like pretty much how most of software development is done today. One way of finding the sources of disagreements and figuring out shared understanding is for somebody to present overall goals and then come up with potentially problematic scenarios where people get asked to individually write down what they think should happen in that case and present it back to the person showing the goals. That's a feedback, so this whole thing is called the feedback exercise. Which means when you're discussing examples, don't shout out loud the conclusion, don't claim the truth, just write your opinion down and compare everybody's ideas at the same time. This forces all the team members to think deeply about an edge case scenario, prevents people from influencing each other or just relying on somebody else like a domain expert being right. If all the answers turn out to be the same, then you have solid shared understanding. If there are differences in the answers, then you do not have shared understanding. And it's important to figure out why, so we can start talking about why. Why do you think this was like that? Why do you think 99910 should be approved? Once we discuss these things, we get closer to shared understanding. Repeat this process a few times with several other scenarios until the answers converge. And that's effectively a feedback exercise. So if you read between the lines, what Klein talks about is effectively the same as what Weinberg and Gauss talk about. Concrete scenarios are easy to argue and complain about, to surface disagreement and misunderstanding, unlike general requirements and goals. But the interesting aspect of what Klein describes is how, when we have a discussion with the whole team, we should actually get individual people to write down what they think happens in a specific edge case scenario without discussing with everybody else. This forces engagement, this surfaces misunderstandings and disagreements. If you just get the examples from somebody like a domain expert, it's easy to glance over them, and you might not notice that one person has a different opinion from everybody else. If you have to participate in providing a written answer, even if it's just a number scribbled on a post-it note or pasted into a Zoom chat, then everybody actually has to show and visualize their understanding so we can argue about that. Combined with the use algorithm, feedback exercises effectively mean that the U and the S step are done together, and for the E step, for the edge cases, you come up with inputs as a group, but don't discuss the outputs immediately. Instead, Get people to individually write down what they think the outputs are for these inputs, and then turn them over and discuss them. This is amazingly quick, and it gives you a solid way to measure shared understanding, expose disagreements, expose blind spots, and produce a much more complete set of examples and requirements you can use as acceptance criteria. Please, 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 don't treat your BDD scenarios as requirements. They are not. They are a way to clarify requirements, ideally help organize a good fight about the requirements, and get people to complain faster than they would if you had implemented the software in the first place. Don't be satisfied with the usual examples, things where it's clear that something should happen or shouldn't happen. To get the complaints out, find the edge cases, find the boundaries where people might disagree. If you get such examples from your business stakeholders, that's amazing, but it's just the start of a discussion, not the end of it. Apply the use algorithm, apply the feedback exercises so that you can actually find the real requirements.